Hey, hi everyone. I hope I am audible. Okay, so welcome to the Dev Day. Uh, I'll just give you a brief about what the Dev Day is if you are joining for the first time. Dev Day is a monthly event that we do at Sahaj. It covers variety of topics, including technical and few non-technical stuff as well, ranging from Kubernetes and what we have it today for API and containers and everything. Any topic technically that is appealing, we try to present it to the people, get their reviews, and also if you have anything that you want to hear more about from us, you can also share it with us. So today we are having Sudarshan Balaji with us, uh, and he is giving a talk on robust API design. I'll hand it over to him. Hey, Sudarshan, it's
Thank you so much, Amit. Happy to be here. Today's a long-standing effort. So today we are going to talk about robust API design. So I want to give a quick overview of the agenda of the talk. We're going to first go over what are APIs. I just feel like there's an inside joke. So we're going to go over what are APIs and what do we mean by robust. And then we're going to start with a very trivial problem. Then we're going to have an API to start with. Then we're going to do quick sweeps, just doing some minor checks. Then we're going to learn to highlight chains and not take shit from anyone. Then we learn to not overcommit. And then we are going to find the one. And finally, we're going to check if we are robust after all of this and what next. We're also going to talk a little bit about over the wire, which is the API, which is outside the SDK, like over the network, how do you communicate with APIs? So that's about it. So this talk is prepared by.
Hey, Sudarshan, yeah. So I think people are saying not audible. Hey guys, are you not? Is Sudarshan not audible to you guys?
Oh, so sorry.
He is audible.
Okay. Okay.
Can you confirm again? I changed the mic. It should be slightly better, hopefully.
Yeah, you're audible. At least.
Okay, cool. This talk is presented by me, Sudarshan Balaji. I'm a solution consultant in the UK. And I've been writing code since 2003, and I've been professionally delivering value using code since 2013. So a little around 9 years I've been doing this. This talk is also thanks to a lot of people who have provided feedback on early versions of this talk. So I just wanted to have a place to thank them. Let's begin. What are APIs? So firstly, I'm not going to do this. I'm not going to talk about what APIs are, but I want to understand what do you think are APIs? Like when I say API, what comes to mind? A few responses from the audience would be really helpful. Okay, so I should have brought some plans to the audience who will just give me dummy answers. Let me actually go about answering if nobody else wants to. I'm going to wait for like 5 more seconds.
The first thing which comes when we think about API is that calling some service and getting response in JSON.
Nice. Anything else?
And the full form application client interface. That's it.
So application programmable interface. So what does a full form actually refer to? Is it calling service methods and getting JSON?
That's not necessary. Can be other types of.
Like what?
It's just a way of communication between computers, programs, or between software.
So is it across processes? Is it across process when we say communication?
Yeah. Have this communication across processes also.
Is there communication within process that could also be modeled with APIs?
Within processes. So are you saying like we have a service that has multiple minor services inside, like microservices inside, and the communication between them is via the API? That could be done if it's a single server. That could be done via because it's in the single server. So you could have other ways of actually passing information rather than using the APIs. Right?
Okay, so I think most of us are familiar with service calls being APIs, and also inter-process communication, there being APIs in the context of inter-process communication, whether remote or not. I think we understand that. APIs are also just the interfaces that you engage with. If, for example, we have a client interface and we're calling functions on a class, that's still the API. It's just the public interface of that class. It's a bunch of functions that you can call with certain inputs and receive some outputs. So it's actually those APIs that we're going to deal with today. We'll probably extend it to the web APIs at the end of the talk, towards the end of the talk. That's the over the wire section. But we're mostly going to talk about APIs in the context of modules exposing their functionalities via their interfaces, right? And how do we go about designing these modules, and what does robust mean? So given that context, that any function you call in your code, like let's say we are writing a Java library and we are making a function call, which is part of another module or a package, and we're calling a function in a class, a member function. In this context, what does robust actually mean to you? What do you think robust really means in the context of this? So the point of this talk is not for me to have some questions and then provide you with answers to those questions. It's more about I'm also trying to think of a few concepts, and I want to share, hey, there are these ideas that are popping up in my head. Can we have a discussion around these ideas? So it's not that I've already thought about some things and I have solutions to offer. It's more like a joint thinking exercise. So if we are not able to move forward because there's not enough interaction, then I will be forced to just go with whatever I thought about. But I would really like to know what all of us think about when we say robust. So if we say, I want to deal with a robust system, or I want to deal with a robust API, what do we think that means?
So I could go first. So robustness for an API, what I have in mind is basically providing you with the same response. Anytime you pass in request, it needs to provide you the same response. It never changes, and it has a predefined set of what do you say? Predefined set of restrictions. So it has those things. That's what that popped into my mind here.
So I think that you're covering aspects of consistency, like API is consistent or in some way deterministic, and it's kind of well defined. When you say there are restrictions, you're probably talking about, you can correct me if I'm wrong, that an API is well defined, that you have some guarantees around it. Right? Does that make sense?
Yeah. People are putting things in the chat also. So you better
I'm sorry.
check that as well. Yeah, they are.
Okay, I didn't see having asset interface between server and client. Simply abstractions over repeatable tasks. Okay, I think I missed some of these. I'm really sorry. Covering all possible use cases. Okay, interesting. Having proper access and authorization. Sure. Great. I think a lot of these points are things that I also thought about when I think about robust APIs. But there are certain ways in which I think about these, and I just want to lay them out. So let's see what I have thought about in terms of robust. Robust is basically meaning several things, but everything's kind of interconnected. And probably when we go over them, we'll see how they are interconnected, even though they are probably having different titles. So one of the first things I think about when I think about robust APIs is that they are accurate, that they accurately model the system underneath, that it closely resembles reality, and the impossible things are impossible via the API. So when I have an API for a coffee machine, I can't buy a shit with that API, right? So because I can't do that in a normal coffee machine, that should be impossible, right? But I am able to make espresso in that. So I should be able to do that via the API. So that's what makes it accurate for me. It resembles reality. Things that are impossible in the real world or in the system should be possible via the API. And things that are not possible in the real world via the system should not be possible via the API. And another aspect is self-documenting. Like a robust API clearly communicates the intent by using the right types and signatures and methods and the right availabilities of these methods. For example, while creating a resource, maybe a particular key is not available, but once it is created, that particular key is available. So that's kind of availability of properties and methods, an example. And also we can think about aspects of security. Like when we say secure, it might mean different things like access control, authorization, right? But I think we can also look at it as, hey, I should not be able to waste any resources by the consumption of this API. Like this API shouldn't let things go waste in consumption. And also it doesn't share information unless required. So this sharing information unless required kind of covers functionality, exposing the right functionality to the right kind of consumers, and also stuff like authorization behind it. So I'm just using generic terms to encapsulate a lot more than what is typically thought of as security. And also reliable. Robust APIs need to be reliable, which means they give me some way to make sure that what I'm doing is actually the right thing. And it should be impossible to use an API incorrectly. And APIs which lead you to not have too many ways of using it incorrectly typically end up winning in terms of robustness. They're very reliable because it's very hard to use them incorrectly. So they kind of force you in some way using either static type checking or other mechanisms like hypermedia and the REST APIs. There are other mechanisms, but the mechanisms don't matter. What matters is that they are reliable. They make it really hard for you to use them in an incorrect fashion. Another point is that APIs are performance. So I know this is kind of even so far we a little bit blurred the line between implementation and APIs. I'll be like talking about secure and reliable. Reliability and security and performance are usually delegated to like implementations, and they're not really thought of as concerns of APIs. But as I mentioned earlier in the abstract, let's just suspend this idea that some of these are implementation concerns and let's see where it takes us. Can we actually do performant APIs? So a performant API basically communicates change really clearly so that you're able to understand just from the API, hey, I can cast this result. I cannot cast this result. And just having signals like what could be cast is kind of helping you towards building more performant solutions. So that's kind of one way how an API can actually make things performant. But there are several other ways. I also think robust APIs makes things effortless. Effortless in several contexts. For example, a really good API reduces the effort to implement it, reduces the effort to test it because it really makes impossible things impossible. So there's not much testing going on. And you have fewer bugs because the API is really good. Any implementation of that API naturally avoids a lot of bugs. So a lot of debugging and bug fixing effort is kind of saved. And all of this is not only saved for the implementation of the API, it's also saved for consumers of this API, which can again be abstract or actual implementations. So these are generally the aspects I'm touching upon. So we can already see that there are some connections between these, like an accurate API kind of makes it effortless while also making it secure, because when we are trying to model the system very close to reality, if something is not possible, for example, if you don't have a car key, you can't enter into the car. And if that's accurate in the real world, an API which models it is also automatically secure, because there are security models in the real world that can automatically be translated into these API systems. So I just want to go over a problem. The trivial problem we are going to take up is tic-tac-toe. So I hope it's a simple problem which we all understand and easy to translate into code or interfaces. So just to outline, tic-tac-toe is a game played on a 3x3 grid with 9 empty spots. And 2 players take alternate turns. They place X and O respectively, alternatively on empty spots. And when a player gets their sign on all the spots in a row, a column, or a diagonal, they win. So the objective of the game is to win, obviously. And the game ends in a draw when players run out of spots and nobody wins. So basically, maximum of 9 moves. Right? So this is a simple problem. So if we were to go about creating an API that will let a consumer of our API construct a game that's playable by 2 players, X and O, it seems like a really simple thing. So let's probably start there. I just want to make sure that all of us understand the context. So is this clear? We're trying to write an API that will help somebody else write a program where 2 people can play tic-tac-toe. Is that clear? I'm just looking for 1 yes or 2 yeses at this point.
Yep.
Cool. I'll take the 1 yes. And let's actually look at an API to start with. So this is just a very initial attempt at what this API could be. So please let me jump into some code. So to set some context, maybe let's define some simple code things like there are 2 players, and I hope you can see the code. Are you able to see the code window?
Yes.
Yes.
Okay, thank you. So I'm just going to split down, and I'm also going to talk about positions. So we're going to have a position. So this is our package. So there's a code package. There are 2 core concepts we need to think about. There's this player, there are 2 players, X and O. So I'm just treating them as data. There's no behaviors at this point. And there are 9 positions in the tic-tac-toe grid. So I just want to represent these using enumerations because they're very simple to reason about for now. And I just want to split on the right, probably split this down again, just so we can see all the code that makes our solution at the same time. And I probably want to split this again, but let's just think about our API. What do I need to actually make this work? So I'm going to write a small console app, and I'm going to minimize some things that I don't need. And so this is my main function. So I'm writing a console app in Java. I'm saying, I have a code namespace and a V0 namespace. I'm going to import stuff from there. I'm saying, hey, I have something called a game, and I want to be able to play the game for a particular player and at a particular position. So that's my initial idea of going about this. So I'm going to split this down again. And here I'm going to actually create my first game. Okay, I just have to move the zoom thing around. So here I have the first version of my API for a game. So notice that we're not writing any implementation code. We're not writing classes. We're just dealing with the interfaces. So ignore this error here. It's just going to say I can't instantiate game. That's fine. We're just going to talk about the APIs. Okay? So the V0 is basically going to look like this. I know that the game has a current player. And I know if the game is played by a player and on a particular position, because like X plays at a particular position and O plays, right? So this is our initial question of the API now. What do you think are the problems with this API? If there are several, I would just like one problem for now. So I'm trying to build a UI kind of on the console, right? So do you think this API is enough for me to actually do that?
No, once you actually win, how do you notify that person?
Okay, so you're thinking about how do I notify winning? So right now, how do we actually collect input from the user? Let's say I'm writing this console app. How do I collect input from the user? Say, hey, this is where you play.
The play function.
So if I'm actually writing a CLI app, then the coder is not actually providing me. So let's say there is an input passing, and I'm trying to pass what the input is, right? So I need basically the program to interact with the screen and the keyboard and basically get inputs, right? So I'll probably have to use something like scanner or an input reader or something. And I'm going to get a string input or something, and I'm going to convert it into a player and a position, right? So now when I want to do this interaction with the users, I actually need to also convey what is the state of affairs right now. So people can actually say, hey, if there is X at the top left, maybe I won't enter top left. Maybe I'll enter top center. So we need to give some feedback to the users that, hey, this is the current state of the game. And right now, the API doesn't really give us that. So there's no way for us to know, hey, what is the state of the game right now? So it's also one of the defining features of the tic-tac-toe game itself, that there's always a board representation. And at every point in the game, there is like a player signed at some position, or maybe nobody has signed at a particular position, right? So we already know like what players look like and what positions look like. So we still need to think about how will a consumer of this API be able to do anything useful with this API, right? And sometimes that means exposing some state, sometimes it means not exposing some state. So in this case, there's no way that a consumer of this API can actually meaningfully interact with this API unless some state is exposed. So we're going to think about what that state could be. And the simplest thing is I just want to print the board. So I want to say, hey, I want to print what is there in this game right now, so that people have some idea of what's going on in the game, and then they play the next one, right? And right now there is like nothing I can do. So I'm trying to create a print. So I just want to show as an example, I want to say, hey, this is the current player and this is the current game board. This is what it looks like. So I want to print. So for example, I just want to say game.print, or I want to say print.game. And I also want to again say, after you play the move, I again want to say print of game. So I need a function. If I have this function, it's going to print the game for me. Then I can kind of use this to progress and say, hey, print, get the input, play the move, and then print again. So it's like a repetitive loop. So that's something that is kind of useful. But for me to print the game, I need to be able to know what is there at a particular position, right? If I know that there's something there at a particular position, I can basically convert that into a string, and otherwise I can use a like underscore or something and be able to print some code, right? And right now there's just no such way to do it. So that's what I want to do first. That I will basically make a V1 API, and I'm saying, hey, I just have like one more function from the previous version, where I say there's a function called player@, which takes position and returns me an optional player. It returns me an optional player because the player might not have played at the position yet. So it might be like empty, or a player could have played at the position, and then the game will basically return me that, right? So once I have that, then writing this asstring function is kind of easier. So if I change the namespace to V1, you'll see that the errors disappear. Now I basically need a list of questions, and I'm going to take the player at that question, and I'm going to say, hey, if there's no player, use an underscore and join them using space so that there's some space. And then I'm also going to join different rows using like a new line symbol. And basically now I have a way to print the state of the board. So that's what we're basically doing. The thing to understand is that at some points we might create some APIs without really considering what would make this useful, and that's what we don't want to do. So this is a kind of the first thing that I wanted to talk about, which is doing the quick sweeps. So when you write motorcycles or cars, there's thing you do called sweep, where you basically look around quickly to make sure everything is covered. So that's kind of the idea here. We want to do some quick sweeps and make sure that the API sufficiently exposes operations that are required to build useful stuff on top of it. So like always try to think of a simple UI to verify whether this API is sufficient. So in this case, when we thought of like having an interface communicating with the user, but I need to show them what things look like, that's when we kind of understood that we need this player@ kind of an API. Right? Obviously, we could have a wide show and stuff like that, but we don't need those. We just need this minimum API to get things rolling. Does that make sense?
Yes.
Okay, thank you. I'm sorry, I may need to stop asking this question, but it helps to know that the idea is like making sense, because maybe they only make sense in my head, right? So the I'm so sorry for the spoiler, but the other kind of problem I have in this API right now is that I have a function called whiteplay, and here I'm saying, hey, print this game, and here I'm saying print this game. So game is just an input to this white function. I already know what print is doing because I wrote this, but I don't know whether this print game will yield any different results than this print game. Again, notice that I don't know anything about the implementation. So I'm just trying to find my way just using the API. I'm trying to understand what to do, what happens with this API, right? And it's right now not very clear. So when I just call play, there's no indication that there could be a change in the game. So maybe this print game, I could just cache the result of that and use it again. Like imagine that this string as string, maybe I could just cache the result of this because maybe the game doesn't change in between, right? So right now it's not very clear if I can cast the asstring's result, for example, the string representation of the game. It's not very clear because it's not clear that play actually changes the game. For example, if I had a white show method here, which doesn't take any inputs and just prints it to the screen, if I call that method twice, I wouldn't really know if that changed the game state or not. So the first thing to do in an API is that we need to communicate the change. We need to highlight it. We need to say, hey, this will actually change something, right? So and the easiest way to do that is to basically change the return type of this. to gameplay, and thereby the API is just telling you that, hey, if you call play, something's going to change and you're going to get a new game back. Now it could be a new game or it could be the same game instance, but the API is telling you without any implementation that there could be a new instance of game. So that's what we are basically communicating with that API. So I'm just going to go to a V3 game where we just made that change, and we're just going to update it to show how the consumer's code is going to change. Now, because I know that the new game is being returned, I can say, hey, game played was game.play, and here I can just pass played. And I know that played is different from game, and I know that this cannot be cast because like asking of game will be different from asking of played because they are two different game instances. So this is like a small way where we communicate that, hey, when I call this function, something actually changes. And we are doing that with no implementation code. And we can actually understand just by looking at this API that, hey, when I call play, something's going to change, right? And I probably think I jumped over a version. I'm really sorry. So it should be here where the play is again taking just player and question. I changed V to here, but I put it something else. So I hope that makes sense. The small change we made was we went from white play to a gameplay, and that's basically what the slide is talking about. Highlight changes. It's as simple as return type. So if we are changing something, if we make sure that the API returns a new type, it kind of indicates that there could be some change. Not that there is always some change, but there could be some change. And the consumer is left to deal with, hey, do I want the change or not? So for example, in this example, I could always say, hey, game.play, but still print the game. I don't care about the game that you return to me. And that's a totally a call that the consumer can make. And they can not use the returned instance, but that's a conscious call. They do know that play returns a new game and they're choosing not to use it. It's not that the API is abstracting away the information that something changes. It's just the consumer is choosing to ignore that. And we can't control consumers, but when we write APIs, we can obviously give more information about what's happening. So that was the point about highlighting changes. I just want to quickly make sure my next slide doesn't again spoil things. So what's the other problem here? So does this actually accurately describe the system? So we say, for example, game.getPlayer, because we know that there's a current player for the game. We say, oh, game.getPlayer, and then pass it back in. But there's nothing that really stops us from saying, hey, game.getPlayer is player.o, for example, and this code doesn't break at all. It doesn't complain of anything. So the API doesn't really tell us that this is wrong. And this is not something that's usually dealt at the API layer. People usually think, oh, I'm going to write some tests and say, oh, invalid player, throw it. But the API can actually do more than let you deal with such problems. So the API can actually tell you that some things are not possible. So for example, you cannot actually pass O as the first player. And how do you describe that with the API? So like one of the ways maybe we can think of is just say, oh, player.x is the only thing you can pass, and you know that's not working in Java. So what really can we do to make this work for us? The API, I don't want the API to actually work in this fashion. When I say the API to work, I just don't want this code to compile in Java if I pass this, if I like to write code like this. Okay. Go on.
Yeah, someone is saying custom exception.
So custom exception, yeah. So exceptions are one way. For example, basically I can say throws, invalid player exception. So let's say we do this. This is totally one way. But when I say invalid player exception, it's not really communicating when it is an invalid player. For example, there are two cases where this can be invalid. One of the cases is obviously you give player O as a first. The second case is you do take player X, but you actually I'm going to create another game called gameplay 2. I'm going to say play.play because now I'm dealing with the second game, but I'm giving the same player. So this is also supposed to fail because there are two. I just want to ignore this because it's showing me an error here, but it's not a different thing. So basically here, I'm trying to pass the same player in two different moves back to back. And this should actually not happen because in tic-tac-toe players take alternating turns and the API is giving us no such information that, hey, like it's not an alternate turn, right? So one of the problems with this is basically because we expect the consumer of this API to basically say, hey, pass me the player that is currently here. So we actually expect to be doing this, where we say, hey, pass me the current player and I'm going to work every time. So that's kind of what we're saying. And this is a really poor API because it creates a dependency between an output and an input and it doesn't make it really clear. So one way to resolve this is to just get rid of the player input and say, hey, I know which player to play with. You don't need to tell me who the current player is. I'll tell you who the current player is, and you can't change that. So we basically take this power away from the consumer of this API to do this. So we want to not have a player input at all. We can always print the current player because we see this method will still work. We're going to print the current player, but we're not going to give the current player as an input. So the game kind of knows who the current player is. So this kind of leads to fewer bugs, fewer exceptions thrown, fewer tests. In general, it simplifies the API and also communicates the fact that you are not in control as a consumer of this API to choose who the current player is. Just like in tic-tac-toe in real life, there's like one after the other is like implicit, and you don't get to play two moves as X or something else. You don't get to choose who the next player is. It's kind of dictated by the game. So by making the API in this fashion and removing that input, we are actually moving closer to reality, making it more accurate, making it more self-documenting in all these respects, right? So if we just look at this, this is the change that I ended up making in game V3, which basically has this change. Notice that that's the only change. And if I make this into a V3, this is no longer going to fail for any reason, right? So this is the other part I was going to highlight. After highlighting changes, we also need to look at
one question. Can I ask a question?
Sure.
So in the previous screen, if you could go up the previous screen.
So yeah.
Yeah. So I mean, I think from a readability perspective, this seems less readable than even though it's possibly correct and it's being enforced. If I'm just looking at this main method, if I instead had something representing the two players, then yes, sure, it would be throwing an exception, and that would be something at runtime and not compile time. But even this is not really giving me a compile time indicator. I mean, it's sort of implicit, right? So how is this an improvement? I'm not sure if this really is an improvement.
It's an improvement because you cannot really create invalid states. We're using the same API at compile time.
But you don't know who's playing at any point, right? Unless you print
you
it.
do know, right? Yeah, I mean, you do know. It's not about printing. The game is still communicating who the current player is, but the game is also communicating that I control the player and not you. So you cannot really pass me some player. I know who the current player is. You can also know it if you query it, but you don't get to change it. There's no user changing the current player at any point in time. Like when I say user, the consumer of this API cannot change who the current player is. That's what we're kind of communicating.
So typically, when you have this kind of thing, so I mean, we can agree to disagree on this part, but I think the readability of the previous one is better, even though it's not aligned to this. So typically, when you kind of have this kind of an issue, you normally have a case where you assume that the caller will check whether the object is in the correct state before making a call, right?
Correct. So that is the perfect example of a really bad API in the context of what it's doing, because it's not communicating. For example, map is a really good example. When we say map has a contains key, and then you have this map.contains key, and the caller is expected to call this method and then call like map.get, which is why it actually throws a key not found exception. So a key not existing in a map is not really exceptional, but it's exceptional because the caller is supposed to make this check. And if you make this check and then still make this call, then it is exceptional that you don't find the key. But this is a really bad API because the API doesn't communicate to you. Just when you read the API, there's no way for you to know that you need to make this check before you call this. And that's the lacking in that API. That if an API creates a situation where there are a bunch of methods and the API forces you to use one method over the before the other, but it doesn't tell you this, that you need to do this, then you need to go and read some documentation to learn that. Or you basically run the code and then it errors or then you learn that. So APIs which have some implicit ordering, but they're not explicit, are bad APIs because they're not telling you how you can go wrong. They're not forcing you into ways to use it properly. There are higher chances to make mistakes with those kinds of APIs, which is kind of what we're trying to avoid.
I think that point I take, but I'm just saying from a readability perspective, I just look at this main method. It's just nudging the game class into different states, but I mean, I need to read documentation to say that it's nudging. I don't know which is which. There
is no documentation. I mean, what is the nudging from documentation? Forget about this main class. Let's say
I don't know which one started which sign played first. How do I know that?
Which what?
Which sign played first? If I just look at the main.
Why do you need to know that? That's what I'm trying to understand. As a consumer of this API, why do you think you need to know that beforehand? All you need to know is there is a player for the game at every point in time. And at every point in time, a player plays. You are not really thinking about player playing the move. right? You're just thinking about playing some positions on the game. This idea of having to represent a player as something that has behavior is outside the scope of this, right? The API is not trying to give behaviors to anything that doesn't need behaviors.
Okay, so I'll hold back. I'll see where you take this.
Sure, we'll come back to it. I'm sure there are, like, again, it's just a thinking exercise, right? I'm again saying I'm not saying I have all the answers. It's a good thing to just think about, like, where APIs can fail and how we can make them slightly better. So this don't take shit point is basically about don't take inputs that should not be provided as inputs. So in this case, like, providing a player as an input is something that should not be done because that's gonna give rise to way more failures and we need to control them. It's just much simpler to model it close to reality that you don't have control over who the next player is. And we are just talking about, again, just the API. So just to quickly check, I think I keep losing my speaker notes. So the next part is not to overcommit. So overcommitting is basically promising that you can do more than you can. Like right now, I'm trying very hard not to overcommit that I have all the answers. I'm saying I'm just trying to have a discussion. That's me not overcommitting. Right? An API, when it has a method that you can call, it means that you can call it at any point in time and it's going to do its job, right? And that basically means if you do have some API signatures which are not valid, better not have them. So as an example here, this is not a really good API because, for example, this position may not be available to be played at any point in the game. This is a valid example. So this should actually fail because I'm trying to play at the same position twice and this should not be possible. The moment I played at this position should become impossible for me to play at because in tic-tac-toe, you cannot play there, right? If you really think about it in respect to the accuracy of the system that we are modeling in terms of the API, in the real world, it's not that you try to make a move and then you fail, right? You're just not allowed to make that move at all. So trying to do something and then failing, throwing an exception and handling it is like a very programming way of thinking about things. Rather, we can actually think about what really happens. Like, so how do you think we can deal with this problem? Like, I should not be able to allow to play at a position which is already occupied. So if you look at the requirements, it just says you're allowed to play on empty spots. How do you deal with this at the API level? That if I do try to write code like this, it should not compile in Java. Okay, so at least one of the things I can think about is we are trying to play at a position, but there's this idea of a move being played that we currently do not have. And the idea of empty spaces being present or there being only a few positions where you can play in is just not available. So one thing we could do is definitely say, for example, hey, get me a list of positions that I can really play in, right? And I can say, hey, I have a list of positions or maybe an iterable of positions and get one of these positions and pass it back in, right? That's a reasonable way to do it, where we say, hey, there are only certain positions for you to play in. You give me one of those positions, right? But again, it brings back the same problem where I'm expecting the consumer to call this API first and then take one of the inputs and then pass it back to me. This is very similar to having a player here and saying the consumer should call get player and pass me back the same player and then I will work. It's a really poor API design. So instead, what we're trying to do is expose this idea that moves are available to be played at certain positions at every point in time. And we can still try to do that. So if I do not want to do this, if I don't want to give positions, then maybe I can give this play function itself as an iterable, and I can say, hey, you can actually play at one of those. So if we think about the move itself as an abstraction, I think we can close this position for now. So a move might look something like this, where we say, hey, every move has a position, and every move has a player, and there is a make function. So this is almost like waiting for this function call. So earlier, you remember that we removed the player argument from the play function for a different reason. So here we're going to again remove it for a different reason. So here I'm trying to import all the code. So if a move really looks like this, then again I can say, hey, I have a bunch of moves. So why don't you get the moves and So now I'm probably going to import, because the other one is defined at some other package. I'm just going to import that here. So I have a v4 dot star. There's a move in v4 which I'm trying to use, and I'm saying it has a position on a player, and there's a make function. So this make is very similar to this play. It's just going to pass these into that. And right now we don't need to pass the player at all. But I'm saying every move belongs to a player. So if I had such an API where I say the game has like a bunch of moves at every point, and you take one of those moves and then you make that move and you get a game back, and you no longer have this kind of an API, then this is obviously going to have to change. I'm going to come back to the console a little bit later. So let's look at what this API actually communicates and if it's actually correct. So here we are saying that at every point in the game, there are a bunch of moves. You get one of those moves and then you make that move. And if I want to print to the user what this move means, I can always use these. I can say what the get position is and what the get player is. Basically, print those to a screen and say, pick one of these. And whichever one you pick, I'm going to just call the make function on that move. This kind of looks like it's solving the problem, but it brings its own set of problems. So firstly, it says there's a bunch of moves, but it doesn't say anything about the nature of these moves when it actually can. For example, this could have just been a list of moves. The reason we don't want to have a list of moves is usually a list means it's a collection that can be modified. Like when people can add or change or remove items from this, that's when you use a list. And IEEE just makes it simpler that there's a bunch of things and you can't really do anything about them. You can just go over them one by one. That's actually also communicating that. But moves can now be non-distinct, which means that the same move can exist in this list like 5 times. And that's not something we really need. So another thing we can do is basically make it into a set. And when we do make it into a set of moves, we are saying the moves are unique. But what are they unique by? Are they unique by player, position? Are they unique by this function? It's not very clear because sets are usually like unique at the whole element level, which means even if these two are the same, but they have different make functions, it's going to be unique, which is not really true and it's not really accurate. But before then, let's just look at what it means to have a player in the move. It means that when I have a set of moves or a bunch of moves or a list of moves, then those moves could actually belong to different players. It's actually not the case because that's impossible. At every point in the game, only one player can play the move. So this cannot be here. There's already a player here. So if you want to know the current player, we can get it from the game. So there's no need for the move to have it. But every move does belong to a position. So why can't we just say this? Again, it's because of the uniqueness not showing up. It doesn't say that the moves that are as part of the set, they cannot belong to the same position because every move belongs to a different position, and that's not really communicated. So if we were to do that, we could actually say we have a map of position to moves, and this map is actually guaranteeing that moves are unique based on position. And once we have this kind of setup, we are communicating that every move belongs to a particular position, and all the moves belong to a single player. So just by changing this API, how we started with like an IEEE of positions and a gameplay, and by changing how we are looking at this API, we are communicating way more about the game, and that we are right now saying that moves are unique on position. It's not something that we were doing before. In fact, when we did the play comma position, it was still there. When we say play position, we are kind of equating one position to one move that we are playing. So that is unique. But when we try to change it into an IEEE of position, we kind of lose that. So while making these transformations between one API and the other, we need to keep in mind what we represented earlier. Is it getting lost? Because that was actually accurate in the sense that you could only play at a certain position. But once you introduce like an IEEE of positions and do away with the uniqueness and stuff like that, that is gone. So we need to retain that. The still map is a really poor API in other aspects. And also once you have a map of position to move, you kind of don't need this position inside. So move can just be move game. Move can just be an interface which has a single function called make, and the information on what position it's being made against is like baked in, and you don't need to get it from there. You can actually get it from here. But again, map is not a great API because map is again a collection, and it means somebody can change it. So the better way to write the same API would actually be something like take an optional of move, have something like get move at this position, and basically say position. So get me a move at this position, and if it could be available and not available. It's very similar to the map API. If you really have a map, this is what it will also mean. But here we are actually, because we are making a functional interface, we are kind of locking down the idea that it can change. If you did have a map, maybe somebody could change that map. But because you no longer have a map, there's nothing to change. So there's no possibility for somebody from outside to even think that they could change. That's just gone away because we are now saying for every position, there might be a move, and you get to make that particular move. So this is going to obviously change. So I'm going to switch to actual v4 game here. So this is a V4 game that we already had, and I just showed you how we arrived at this particular API. So I'm going to show how this will change. So instead of having this kind of API, we're going to have this kind of API, and here we're going to say, hey, take the move and make it. So here I can actually say move, make, because that's what I'm doing. So once I make the move, I'm going to get this is a V4. That's why it's actually completing. So now we have a move make, and I can or else throw. So notice that I'm still trying to throw here, but the throwing is happening outside of my API. My API itself doesn't throw. A consumer of my API can choose to throw or do something else. And that's not really my concern. As an API author, I just want to make sure that my API is like really clear. So here it's again, you're making a move and move. Or else throw. This is just so that I get the code to compile. So here it does raise the point that we have changed the API a lot, and it does feel like you are having to do a few more things in order to make things to work. But always you can encapsulate this inside a single method. For example, we can have a private static game, play at game, pushing. And we can just encapsulate this behavior in one place. We say, oh, now I don't need to actually write all that. I can just say play at this particular position, and this is doing the same thing. So this is to say that just because we're writing a little bit more code at one place doesn't mean it's a bad API. It just means it's composable in different ways, and it can still be made more readable. And we can encapsulate the same kind of behavior, the same code we write in multiple places in a simpler fashion. But the point is that when we introduce this move abstraction, we are again making it closer to the real world, where actually moves are made at certain points in time, and there are only certain moves available to be played at certain points. And these moves are actually tied to a single position. So at a particular position, you only have one move that may or may not be played at the time. And that point is very clear. But once you have a move that you can make, there's nothing that fails. So once you have a move that you can make, there's no failure, there's no exceptions, there's no handling of those. Right? So it's kind of the way we are moving closer towards a more accurate API. So when I talk about not overcommitting, what I mean is like ensure all the inputs are valid. So if one of the positions could not be played at some time, then there shouldn't be a game.play API which takes a position, which means any value of position is valid at some point. It's just not a valid API. So in statically typed languages, it's easy to create types which encompass valid values. So probably have like a separate type which only has valid values. For example, if you have int and your method only works with like non-negative integers, just create a type called positive integer. And instead of saying int as your like input, just say positive integer input. And creating the positive integer is like another API's problem, but your API is really clear like what it can work with. Right? If a subset of values are not valid at any given time, make that clearly clear to the consumer, not by exceptions, but by saying that, hey, this is only possible at some points. And also provide a way to build valid values so that there's a clear distinction between valid and invalid. So this is the kind of similar point to int and positive integer. When you create a way to build a positive integer, you're basically saying, hey, there's a difference between a normal int and a positive integer, and I only deal with positive integers. That's a clear signal to the API consumers, right? And communicate the possibilities. Like if not all things are possible at all times, communicate that in the API instead of saying, hey, I'm going to throw an exception at some random case and somebody needs to handle it. Make it clear that, oh, this thing is actually only possible at some times. It's not that the other scenarios are exceptional and I need to throw an exception. It's just that, hey, as part of the system, I already know that some of the things are not possible sometimes. And so I can just bake it into the API and make it really clear. So also we can use the type system to effectively do this. In other environments like non-statically typed languages, there are other ways to do the signaling, but the idea is to basically communicate. If things are not always possible, just have that explicit in the API instead of trying to treat things as exceptional scenarios. The final point is to commit to outcomes. So if you write an API and you say, if you give me this input, I'm going to give you an output, commit to that. Like never try to treat it as, hey, it's a false promise and at some point I'll fail. Try not to do that. Think carefully about the result of a function call or creating a class and keep it consistent. Right? And if it's not possible to guarantee that, think about your API again, like rethink. Is there something I can change this API that will make it actually commit to outcomes instead of me trying to say some situation is exceptional? So those are these points that I just wanted to cover at this stage. And then we have like this final one, figuring out the right way to represent ideas. So we went through a little bit of this in the current change. So I also want to quickly highlight what they are. For example, we talked about iterables and list and set and map and how they differ. So one of them is definitely, do you need collections? Right? Use collections like list only when you want customers to add. Like there's also a collection interface instead of a list. So use collections only when you want consumers to add or remove from the collection. If not, just prefer iterables and streams. It's a very small change you can make in an API that makes a big difference to consumers where they really understand what that means, right? Is there some uniqueness to the values in a collection? Probably then think about using set instead of list. It's a very small change. Again, communicates a lot to the consumers, right? Is there a uniqueness not on not on the whole element, but on a property? Maybe then it's a better time to use a map or a lookup or a grouping. So that's another idea to think about instead of just using sets. Is there a missing idea or abstraction? So in the last part, we noticed that there's a move abstraction that we completely missed when we were trying to play at a certain question. Things like this will usually help. Is there an idea that I've missed out? So ideas are usually expressed in terms of abstractions in core. Usually there's an interface representing an idea. So here there's an interface representing move. So that's something to usually think about. What about transitions? So how do you go from one state of the system to another state? So I think I also need to go over a little bit of code to explain this point. So let's say we need to make an undo function. So one of the ways we can think about it is say, hey, I know every time I change, I'm going to call a undo, right? I'm going to return a game. So let's just have a game undo. No, let's just make a valid API. Initially, it might seem like a great idea. When you have not played any move, there's probably not a way to undo. And then you're going to have to think about, oh, throws move not played exception or something. But again, instead of thinking of it as an exceptional scenario, right? When this would really make sense and what is actually happening. So a game is a game which allows you to play some moves. But once you do play a move, maybe it becomes something else. So one way to actually model this is to actually create something called an undoable. So an undoable is just a game, but it also allows you to undo. And how does that actually come into the picture? By basically having a move, which when you make a move, instead of returning a game, you can now start returning undoables because you have made the move. You obviously can undo it, right? So again, when we start thinking like this, our APIs are going to become like way more self-documenting. So here we have the same V5 API, which uses all the other things like undoable and move. And notice that this API doesn't change at all. So the consumers don't need to really change. In fact, if I change this to V5, it's still going to work. The same code is the same because move still returns a game. It's just additionally now undoable. So here I can actually say, instead of this being a game, I can now say, hey, it's actually an undoable game. And oh, because I changed this, amazing. So now it's an undoable. And in addition to printing it, I can actually say game undone equals game dot, sorry, plate dot undo. And this is actually an undone game where I've made an undo and I'm getting a different game back. Notice that I don't know if I'm going to get the same game back, but I do know that when I call undo on a game, the move has been played. That's why I'm able to call undo because I can't call undo on a game. So if I try to call game.undo, it just doesn't exist and it's not going to work, obviously, because it's not defined. And it's being made very clear in the API that once you make a move, that's when you get an undoable back, and an undoable just has an undo method. So via the API, we're still communicating ideas, and there's this abstraction of undoable, the idea of having an undo option after you play a game. It's again an idea that we just introduced, right? So this is a transition where we go from a game to an undoable and then come back from an undoable back to a game. When you undo a game, there's no guarantee that you get another undoable because you don't know if the previous game has any moves or not. So an undoable only returns a game. And when you make a move, you always get an undo. You don't get a game back, right? So this is like transitions. And have you really thought about signaling these transitions and capabilities in the API? So that's something to think about. And the last thing is like, are these really edge cases? Like most things we think about as exceptional, they're probably not edge cases. A good API usually encapsulates all the behavior without having to treat some of these as edge cases. There are very few if conditions in like really well implemented APIs. And this is basically because the API has thought about all these behaviors and encoded them beforehand into the API instead of having to treat some of them as like exceptions, some of them as like scenarios which are not really meant to happen. I'm sorry if I missed some charts, but I think going a little fast. So is this like making sense? Again, sorry for the broad question. Okay, I'm going to take that as yes. So I have a slide here. Are we robust yet? How do you think we did in all these areas? So we basically made some changes. We took an initial API, then we made small changes. And these are all ideas I already communicated that we need to be more accurate, more close to reality, self-documenting, we need to be secure and reliable and performant. So I'll maybe go a little bit over how some of these are I think, incorporated in this API. In this API, for example, it's very accurate. It's impossible to do things that are not possible in the real world. And it's very possible to do everything that's possible in the real world. It's communicating things very clearly, like you can only undo after you make a move. Even those things are communicated without any implementation code. I'm not writing any if conditions, if moves dot length, nothing like that, but the API still says that you can't undo a move unless it's been made. It's also self-documenting because it clearly communicates intent, because it's accurate, obviously. And it's secure because, for example, if I had a method which could be called with like impossible arguments and a lot of things could be wasted, a lot of resources could be wasted, just processing that and then throwing an exception, handling that, stack and roll and all this, all of those things don't occur. So I'm not really wasting resources. Nobody can actually DDoS my system because I don't even give them a function to call. Doesn't share information unless required. So unless somebody asks me, like give me some input and says, hey, can I do this? I'm not really telling them everything they can do. I'm not making them assume what they cannot do. So it kind of makes that secure. We'll probably see how it's more secure when we talk about over the wire, but may not be so apparent right now. Sorry, one.
Yeah, there is a question from Dilip. So Dilip is saying, yeah, it
Why was that
definitely makes sense,
called
but why?
Placing, yeah, sure. I think the naming we can definitely look at whatever makes sense in the domain. As I understand this domain, it's almost like empty spots are also represented as positions, and some of these things we could definitely change, make it align more to the domain and the people who are interacting with it for sure. Placing or signing, whatever works in that particular instance. Sorry, reliable, because we're using, in this case, static type checking to make sure we don't, for example, call game.undo and it doesn't like pass some type checks. But in the case of REST APIs, we'd probably use something like hypermedia. It's also performant because it communicates change clearly. For example, every time I get a new game back, I know that I can't cache some things. But because I know when a change happens, I know, for example, when I call playRat, this function playRat, when I call it, on a particular game, that's totally cacheable. So if I call this function once on a particular game instance, I don't need to call it again. I can definitely cache. So this is again coming from the signals from the API at what is cacheable. I can even call this function once, and I can be sure that it's always going to be cacheable because the resource that it creates are only dependent on the current game and the current position. So these are hints to the API. If I just have a white play, I'm definitely not sure if before and after that white play call, can I actually reuse the game instance? But in this case, I don't have those like kind of issues. Effortless in the sense that because like you notice, a lot of edge cases are avoided just by having this kind of an API. Like I don't need to test if the first player is, if the same player plays a move twice and things like that. Obviously, they are going to be done at the implementation level, but not at the interface level. I don't need to, for example, write a test which says if there are no moves played, undo like should throw an error or something, or undo should not work, or undo should return the same game. Those kinds of tests are completely avoided because we spend time thinking about the API. Okay. Now what? Where do we go from here? So there are additional challenges that we can do. For example, if this idea is nice to play with, you can also think about it's only possible to win after 5 moves in tic-tac-toe. So we can try to encode that in the API and make it really clear that that's one of the conditions instead of writing like behavior tests. It's also only possible to draw after 9 moves. And the ability to check whether the game is a draw can only be present after all the empty spots are gone. So that's one way we could actually say, oh, the API clearly tells me that it's only possible to draw after 9 moves, right? And it's only possible to check whether somebody won after 5 moves. And that's how an API could actually do that. But how do you build such an API? It's also impossible to play after the game has ended and the game ends due to one player winning or like game ending on a draw, right? And because that's not possible, it should not be possible in the API. So how do you communicate those kinds of things via the same kind of API? Then I thought we'll talk a little bit about over the wire, but I have a very simple solution to over the wire. Basically, all the functions are just API endpoints. So every move, it's almost like a function waiting to be played. Like move is just a function interface. It has a single make function inside it, which returns something. So this move, every move could just be made into a single URI, and you just return that URI. And if somebody calls that URI, you're basically calling this function. It's kind of like transferring this whole function calling over the wire. So I think it's like very transferable. It goes well with the idea of hypermedia and REST and capability-based development and stuff. So that's kind of most of what I had. So thank you. I will take questions now if we have time. I'm not sure if we have time, but sure.
Hey, Sudarshan, so if you go back to the part where you introduce the move, right? The code where you introduce the move, right? Now, here, I mean, do you see this part? Like, I mean, in a certain way, I see this part of get, move, at position, right? Which gives you a list of valid positions as an indirect way and a roundabout way to ask is valid move on a position anyway, because do you see it different?
Yes, correct. That's exactly right. But the difference is that the API is forcing me to do that. There's no way for me to make a move without me checking if that is valid at a position. Instead of the API telling me, hey, you're supposed to call this function first and then call this, but the API is not telling me that. I need to go and look at documentation to know that. But here the API is basically driving, that's why the API is self-documenting. It's saying you're supposed to do this first and then do that next, but it's forcing you to do that. There's like no way to make that incorrect, right?
But there's nothing which stops me from using a position got from a previous get move at in a subsequent move, right? So then,
yeah, but you just won't get the move back, right? That's
Sorry?
correct. I'm saying you can use the same position, right? But this will actually throw because this get move at might not exist. So the whole point of get move at is that you can pass positions, but you're never assured that the move actually exists. That's what the API is saying. It's not saying you'll always get a move back. It's actually saying you might or might not get the move back without saying when you will or will not get the move back. So that when you will or will not is controlled by the implementation, right? But the API is still giving you a signal that every time you pass me a position, you might not have a move to play at that point, and you need to handle the situation. Right? That's kind of why it's better. It doesn't remove the problem, it makes it more explicit and forces you to kind of handle it. So here I'm supposed to handle it or throw, or I'm supposed to say, hey, or else just use the same original game, like don't make any changes. But that is still, when I say undoable, it's still not possible because the current game is not undoable. But the resulting game after making a move is undoable. So I can't even do this. So the API is still preventing me from writing code, which is not supposed to work. Does that make more sense?
No, so I think the point is that you can yeah, I mean, yes, it does document it, but I still have to remember that I have to do this every time. I mean, sure. I mean,
you don't have to remember. You're forced by the compiler to do it. That's what I'm saying. You don't have to remember.
No, I can call move.make on a one which I've called before, right? I've called one earlier, and the first time I've cached it. And now I've made a move and moved the game state forward, right?
Correct, but that is on a separate game, right? So for example, if I say here, instead of what have I done here? Okay, so here, notice that play 2 is played on the game and not in played, right? Played is the one which has one move played, correct? So if I remove this, so here I have a played game and I have the original game, correct? So when I call play at second time, I'm actually calling it on the first game. I'm not calling it on play.
I think I get it. I think more of a comment on this than I see what you're doing with it. I'm just commenting why it's fine. I'm finding it a bit surprising. Is that I think somewhere you've kind of combined ideas from functional programming into something which is object oriented. Let me just talk about that a little bit, right? Like for typically in object orientation, there's an idea called command query separation, right? Where something which changes the state of an object should not return a value. Okay, and there are exceptions where that does not hold true, like in a stack when you pop and all that stuff. But in general, if you have that convention that queries are side effect free, then at least in the object-oriented world, you can use those queries much more freely than when you are doing modifying stuff, right? At least you know that, okay, when you tell something to do it, it's modifying state, you will do it carefully with the right caveats. Now, in this, you're basically using a functional paradigm where you're returning a new object or other. It's almost like it seems like a builder returning the same thing, but it's actually more. It's actually giving you sort of game state back to kind of work with, right? And I think somewhere those two paradigms are making it difficult for me to parse it mentally. And I think either going one way or the other is better than a hybrid in my view. But I mean, this is much more of a personal viewpoint than anything else.
Yeah, I think that's true partially because we are trying to indicate change using this returning of a new game instance. And I keep stressing that it may or may not be a new game instance. But the idea is that you kind of represent change in only one way, right? If you have like more than one way to represent change, it's going to be a challenge. So here I'm trying to say every time you change the game, you return a new one, and that's the only way to represent change. Obviously, we can go the other extreme and say, hey, every time I have a void function, I represent change, or every time there's a command result, I represent change. And those are all like valid ways of doing it. It's just that this particular way makes it really clear in just the API without having to follow any conventions. Like I don't need to have command query separation or anything, or any like higher level concepts in addition to just the API. And again, the point is just to have an API which is self-document, and you don't need to refer to other techniques or whatever. If I just read this and this, and this, I should be able to understand what's happening. And that's the whole point of this. I should be able to understand how to consume this and build a valid game with nothing other than these three interfaces, and obviously the position and player enums. But that is kind of where we are trying to get to. And
I definitely see the value of this. I definitely see the value. It's definitely a different perspective to do this. It's just jarring with a few things that, I mean, I've used in the past much more strongly, and I think this is a good perspective to kind of take. I think one other thing which it kind of comes up against is sort of the principle of least surprise. Right? In API design, least surprise is also a very useful thing. I mean, you've somewhere prioritized robustness over a bunch of other things, and that's fine. I mean, that's you're trying to build robustness.
Yeah, it's just a prioritization. Yeah, correct. Right. But there's a different gradient, right? We can.
I mean, it's not a universal definition key. A good API needs to be robust. A good API could be even least surprising in some case, some context. I don't know. I mean, that's worked for me in the past. I mean, if you look at Ruby API, it's very
I think
surprising.
Most good APIs, I'm characterizing good APIs in this way because good APIs make it really hard for you to fail with them. And a lot of these APIs, a lot of the APIs are really good. Like grep is a really good API. It's really hard to fail with grep, but grep does fail. And when it does fail, it's very clear about how it fails. Things like very small tools which are very composable, they're usually good APIs, and they make it really hard for you to use them incorrectly because grep is like a process. It's like has more ways to fail. But a good API really makes it hard to use it incorrectly. That's usually the sign. It's very idiot proof. It's like you don't need much to work with a good API. So most of what you need is right there in the API. It's hard to go wrong. That's kind of how I see it, because not everybody is like an expert. Not everybody can remember a lot of things. And the most, the more we push people to be guided by tools and stuff, like, so here I'm trying to use the Java compiler as the tool. And because it already supports type checking, if I just have like slightly better types to signal to the compiler, it also signals to the user indirectly that, hey, you're not supposed to be doing this. Hey, this is wrong. This should not be possible. Even though the consumer can choose to override it, like things like RL's throw, like where the consumer is like, hey, I know this is going to work. So just, if it doesn't work, throw an exception, right? It's like an extreme case where a consumer chooses to throw away the intelligence I'm providing. But it is intelligence. And that's the value of it, that I am not having to write documentation to describe it. And it still like documents what's happening, and it provides helpful hints to any malicious user. Like even if somebody really wanted to mess up a system, with this API, it's much harder to mess the system up and result in invalid states.
Sudarshan, there is a question from Bhavesh. Why should throwing an exception be the console's responsibility? Yeah, Bhavesh,
it seems like we have tried very hard that our API should not return any 4xx. Okay, so I think that's a valid point. It's I think nobody should be throwing exceptions in general. The API here is just because it's making things very clear what's possible and not possible. It doesn't have any exceptional scenarios. So it's almost like saying, let's say we have a parking lot, and you go to a parking lot and you try to park, and you're trying to write an API for this. Some of the times there may be no space left in the parking lot, right? Now it's one school of thought to think that, hey, it's a no vacancy found exception, right? Or parking lot, no vacancies exception. It's another school of thought to say, you know what? Sometimes when you ask to park, maybe you won't be able to park. And that's actually describing the parking lot better in a sense, because parking lot by nature of it is going to run out of vacancies at some point. And that should be treated as like a normal part of operation, and not treated like, oh, it's an exceptional case, right? Like you really need to handle very differently, right? It's like setting expectations very clearly that, hey, not all the time you'll be able to park, right? So in this case, we are saying, hey, not every position you'll be able to move at all times. So I'm making that very clear. What you choose to do with that is completely up to you. You can totally not throw an error, right? So in fact, there's another way to write all of this. I didn't want to go over how to consume this API too much, because that will take away from the API design itself. But you can actually write a console program with just the API we've described so far. I'll probably share the link to this repo. Just the API we've described so far, you can write a console program which will actually print the whole board, and also print like, hey, if you want to move to a certain point, just type this, type something like this. And you can pass this, and you can only display the options that are possible. And if they display, like if they enter something else, you can just say, I don't understand this command. And this is possible with just using the API we have today. It's like really nice. It doesn't seem like it does much, but it does everything. it also helps you write really robust applications on top. So even if an application tries to be malicious, a robust API guards against it. So with this API, even if an application tries to send me like an invalid player position combination, that just won't happen. Like that's not going to break my implementation, because the API, by virtue of just the API and the signatures, is preventing any invalid states to be reached in a certain sense. I can still write like incorrect implementations and go really wrong, but the API is giving like strong signals as to what is possible and not possible. And it's going to be really hard for somebody to write an implementation on top of this API that breaks the expectations that we have. It is right that just looking at the comment again, we have tried very hard that our API should not return read 4xs. It's kind of the truth. We don't want to deal with any invalid inputs in a sense, because that's wasting server resources. I mean, I could be doing so many other better things instead of spending time validating something and then saying, oh, it's invalid. Also, because validation becomes very implementation specific, it's probably not needed most of the time. Most of the time, people can just deal with, yeah, can I do this or not? And they're fine with that.
The issue is like, as far as I've experienced it, overall, the thinking is right when you're making something which is served to others, no? So like you shouldn't assume their intelligence. If it's wrong, you tell them they're wrong. That kind of approach is always there when you're building things, right? So I don't think that giving errors is a bad thing. I think it's like being more clear about the intention.
Yeah, I'm not against giving errors. I'm just saying exceptional scenarios are exceptional. So if I'm trying to write to a file and the storage system is suddenly removed from under me, that's an exceptional scenario. So then I'll say, hey, I'm not able to save the user data, right? But when I'm trying to save the user data and the user first name doesn't exist and it's required, that's not an exceptional scenario, right? It's not an exceptional scenario. It's something that I expect to happen. And I can definitely say, hey, unless you give me a first name, I'm not going to let you proceed further. That's not me telling the user of some exceptional scenario. It's just me telling that it's not possible for you to do right now. So I'm just saying model these things as not special cases. They're not special. Just model them as normal failures. That there are like things like soft failures and hard failures. That's just like checked and unchecked, right? Like these are runtime exceptions that I can understand that we actually have to throw exceptions, but not when, for example, I'm trying to get a list of moves and that memory address just changed and the JVM crashed or something. Like that's very different from me trying to just get what are my possible moves and not being able to play some of them. So if I say you can't do something, this API will always make you do that. If you can't play a move, you can totally play it. There's no way that's going to fail. That's kind of what we're trying to say. I will commit to giving you stuff that you can always do. So for example, one way to do this over REST API simply via hypermedia is just have like, if you can play for the first time, you basically can say, hey, these are my links, and you just provide a bunch of links or a bunch of URLs where you say, hey, if you want to play at top center, this is the endpoint you call. It's some endpoint, right? And this is basically just going to exist to serve that particular request. And the moment this request is served, this stops existing. Like if somebody else calls this, they're going to get a 400 or 404 for lack of a better thing, right? So then you basically you're exposing what the user can do. Like for example, top, center, top left. Okay. So let's say there are only 2 moves that O can play. They just get this JSON and they can only make one of these 2 API calls. And the moment they make them, they become invalid. So this is one of the ways by which you can just expose capabilities to a user. And you can also say, hey, if you give me a particular auth token, you can also play on the top right, even though X is already played. That's still possible, right? I can say if you're an admin, I'll let you play at any location. If you give me an auth key, I'm going to send you all the locations and URLs for all of them. So this is still communicating that you cannot dictate what is possible, but the server doesn't over-promise, right? The server says, I will tell you what is possible, and you're allowed to pick one of those, unless there are actual like inputs that you can provide to me. So there are cases where you can provide inputs. For example, if I just have an add method, right? Maybe I still have an API like this, but maybe I need to provide inputs in the form of query params. This is totally fine. This is like a case where I need to do something with the inputs, right? But not when I know exactly what this operation means. I can just name it and send it back. I can say, hey, this only means this. For example, when I try to park a bike and I get a way to park the bike, I can't suddenly go and park a car, right? So that should become impossible. There's no use of trying to validate that. I should basically say, hey, if you're telling me this and I'm saying this is possible, you can only do that. In some way, I need to restrict that, right? For example, X cannot play as O, can again be done using some auth or whatever. but things like that. But we are basically saying, even if I don't know much about you, there is some control I have as an API as to what your options are. And that's really important. It actually, I think the principle is called principle of least authority and capability-based development. So they basically say, hey, you have a bunch of capabilities, and I'll keep changing what your capabilities are at every point. And that depends on where you are right now, what my current state is, and stuff like that. For example, who's the current player? And if you are the current player, I'm going to give you like a bunch of moves to make. But if you're not the current player, I'm going to say you can only print what the game state is to the screen. That's a valid API, right? Because I can always print the board, no matter whether I'm playing or not. I should be able to print the board. So it's kind of where it's at. Does that make sense? So this get player and play rat, they always make sense. And for a particular game, they can also be cached, which is pretty cool. Even if you think about REST APIs, you can actually have like proxy caching servers in between, and these can be cached. The same ideas can be used again. Okay, so did I finish ahead of time? Or do we have some more time? If somebody is speaking, I can't hear.
Just curious, since you mentioned about exception handling, can I go ahead?
Sure.
Yeah. So, I mean, I've seen APIs where we have this whole error code scheme and, mapping between the error code and the HTTP status. Like, for example, if the input is incorrect, right, then you give a 4xx, right? And things like that. So I'm just curious about your thoughts on that.
So validation in itself probably is required in a lot of places. The idea is basically to have APIs described clearly and treat some of these as normal operational failures and not as exceptional scenarios. That's all. So let's say, for example, you have an API which takes, like I was talking about, let's say users, or an API that is trying to, I think recently I came across this API where we're trying to make a withdrawal or something. And there's something like you can only withdraw 500 and more or 30,000 and less of the same currency. So let's assume this like INR is a currency. You have a bank account and you're writing a withdrawal API, and the business basically says, hey, you can only withdraw between 500 and 30,000 INR. And that's basically your requirement. Now, there are multiple ways you can do this. One of them is definitely to just write a validator and say, hey, I'm going to look at this amount and say if it's less than 500 or greater than 30,000, I'm going to fail. I'm going to throw an exception, right? That's totally one way of doing it. But if you think about it another way, you can also say, hey, withdraw as a function, as an API, is only going to work with withdrawal amount. It's not going to work with integers or floats or big integers or big decimal. It's going to work on withdrawal amounts. And withdrawal amounts are only possible to be constructed from a big decimal that's between 500 and 30,000. So you're basically breaking it out into two different things. Withdraw API will always work with a valid withdrawal amount, but a valid withdrawal amount has its own set of rules on when it can be created. But once a valid withdrawal amount is created, it's always kind of valid. So if you separate the valid things from invalid things and represent both of them in your domain, where you say, hey, this is a unvalidated or invalidated user, invalidated X, and you represent that, that's totally fine. And then you pass it through a validator, which can return you an optional validated user, right? And then you validate, and then maybe you get a validated user or you don't, right? That's one way to look at it. The other way to say, instead of an optional type, I maybe have a type which can be one of two things. It can either be a validated user, or it can be a validation error, which is another type which describes how it has failed, right? And then I can say, whenever I pass it through the validate, so validate is just a function that takes an unvalidated user as input. And it might return either a validated user as output or a validation failure as output. This is a totally good API. And a validated user will basically be the inputs of all your other APIs. Because the APIs which require valid users, they're all going to take a validated user. They're not going to work with user or like possibly validator or whatever, right? So that, again, your API is being very clear that I don't work with any users. I don't work with users I don't trust. I only work with validated users. And in order to get a validated user, you need to use this validator. You can pass it an unvalidated user and maybe invalidated user, whatever. And then you get like 2 outputs back. It's not that one of them is exceptional, because I think it's very possible that this will fail. I'm modeling it as part of my API that, hey, it's going to either fail or pass. When it fails, I'm going to do this, and passes, I'm going to be able to pass it to my actual service method, which relies on validated users.
So in layman terms, right? So in layman terms, you'd have something like a filter that will execute before the actual method call, right? You get what I'm saying? So your API expects a validated. Is it better? Can you hear me better?
Yeah.
Okay, so I was saying, in other words, you'd have, so basically your
Oh no, I lost Gayatri. Is anybody else able to hear Gayatri?
No, I can't hear Gayatri as well.
Okay.
And the filter itself would, not even call the controller if there was a problem, right? Something like that is what you're saying.
So,
I'm just trying to understand, because
we lost you for a little while. Maybe you need to come over the same point again. Sorry.
Okay, I was saying that if I say that my function or my method or my API endpoint expects a validated input, then I will have to do that validation somewhere, right? So I'm just asking if that would be some kind of a filter or something. Go on, please.
Yeah. So one way, like I was talking about how to think of in terms of REST APIs, right? You can also, for example, have just a valid endpoint, and you pass invalid user details, or like could be valid user details. And then the result will either be like a validation error or a valid user, right? So it's basically you trying to create a resource and then trying to see what you can do with that resource. So let's say you get a valid user URL back, or you get an error URL back, and it's up to you to decide what to do with those URLs. So basically, when you write a client, you're going to say, I'm going to call this API to try to convert this into a valid user. And if it is a valid user that I get back from the server, and this is important that it comes back from the server, because the server can decide what is valid or not and change its decisions at any point in time. As a client, my only job is to say, hey, I need to first validate this. And once I have a valid user, call other API endpoints, which could work on top of this valid user. Another way to do that is to also say, you don't expose what these valid user service endpoints are until that validate method is called. Like somebody needs to call that validate method, and only in the result of that method do they get the access to those other endpoints. So until then, there's no URL that they already know or they can magically create. It's almost like they don't know what to do. They need to call validate and get a valid user back. That's the only time at which they have access to call the other endpoints, right? Does that make sense?
Yeah.
That means your like business logic doesn't get affected, right? So wherever you say I'm going to get a valid user, you are definitely going to get a valid user, because there's no way for other people to even get access to that endpoint to call.
Okay.
Cool. I see Duncan has message on a tangent. We tried something like this self-documenting approach using Spring a while back. It was quite useful, in my opinion, from an API consumer perspective, but harder to implement and model well, considering business logic and auth requirements, both at a bad minimum. So
yeah. So just to expand on that a little bit more. So our domain doesn't always look like exactly like, I'm just talking about the case of an HTTP API here, right? In the implementation, your domain does not end up looking exactly like how the API request response structure may look like. And we found ourselves writing, at least some amount of repeated code or effort in determining those actions and trying to figure out, trying to like basically convey to the user what further actions are possible. I mean, we went ahead with that, but towards the end of the implementation, it became more of, a slight barrier than anything else. But it was quite useful again from like the perspective of the consumer.
So it kind of helps the API independently evolve with respect to the client, because once these operations are commonly understood, you can keep changing what your API implementation looks like. But because the API is frozen on the operations, it's kind of easier to evolve separately. This is much harder when we just deal with URLs, which are like following a certain template. For example, v1/. user/some ID, if that's your user's endpoint, it's very hard to change that. But it's very easy to have a generic GUID pointing to some random URI that internally you use and keep changing that every time, because your API URI endpoints are not tied, because you're using some other ways like links to represent this particular action. You have decoupled like your API structure from what operations you're describing using that. I've had this happen. Like, I think most of the time the questions keep coming up in ways where, how do you use authorization in this context? Like, for example, there are some APIs which are only allowed to be called by admins, and some APIs are only allowed to be called by something else. Like, how do you do that with APIs? The simple way is to just make that explicit. That, for example, if you have the distinction between an admin user and a non-admin user, just have some resource which represents an admin user, like maybe an admin access token, and make that an input to your function. So that forces consumers of that API to have in possession an admin user token to pass to that function. If not, they can't call that function. Again, over REST, this is just like if they pass the admin token to you, then you provide that API URL back. If not, just don't provide that URL back. Have opaque URL. So basically solves those problems.
Right. Yeah.
Cool. So I think we're done for today. Please shout out any questions. Find me on Twitter, LinkedIn, GitHub, wherever you can, and I'll respond.
Okay, thanks so much, Darshan. It's great.
Okay, thanks, Sudarshan. This talk is available on YouTube. I have shared the link in the chat. I'll also share it in the meetup. So yeah. Thanks everyone for joining.
Have a nice day. Bye.
Same. Bye.
Thank you. Bye.